I'm Darrell Wallace, Manufacturing Technical Fellow at BlueForge Alliance, and I'm joined here today by Zac DiVencenzo, who is the president and co-founder of JuggerBot 3D. And we're here to talk a little bit about JuggerBot and what you guys do. So Zac, welcome. Thank you for joining me.
Thank you for having me.
So what is JuggerBot? Talk to me about that a little bit.
Well, so JuggerBot is a designer and manufacturer of industrial grade 3D printing equipment, uniquely capable of processing a wide range of performance thermoplastics. It's a little cliche, however, I like to say that we're more of the Samsung to the Stratasys iPhone. We're located in Youngstown, Ohio, and we've been developing machines for 10 years.
Okay, and what technology are your printers?
So we started out in fused filament fabrication, FFF technology, so thermoplastic materials. And in 2017, we saw a pretty big need to enter into what we call pellet fed additive manufacturing, or what globally is recognized as fused granulate fabrication.
There are a lot of people making polymer printers. What is it about the JuggerBot machines that makes them unique?
So first and foremost for us, it was to scale the technology. A lot of companies were focusing on high resolution, smaller printers, which is easy to use, right? Simple, small parts. But when we start talking about onshoring manufacturing, and we start talking about where some of the biggest benefits are, is actually when you scale up to bigger parts, right? Tooling gets more expensive, metal tooling gets more expensive. You get bigger than, 2 inches, 3 inches. You're getting in the realm of 3 feet, 4 feet. Things are more expensive to produce. And so when we're trying to compete not only globally, but even within nationally, when we're trying to make a sense to 3D print rather than injection mold, or 3D print rather than to cast something using a wood pattern, it's beneficial for us to build bigger machines that have the ability to process the parts that you need. So scaling up was a big emphasis for us. So our product line is called the Tradesman Series P344. It's pellet fed additive that can print 3 feet front to back, 4 feet left to right, 4 feet floor to ceiling. And we focused on pellets. So there is a barrier right now in our industry of materials and how expensive those materials are and what can you actually print with. And so for us to start in a pellet form, when in filament, you start in pellet, and it's just more expensive to manufacture it into filament. So we attacked several barriers. Go bigger, be reliable and repeatable, obviously building a unique industrial system, but also focusing on having the ability to print with materials that are already recognized in this industry. So we want to be able to process something that someone already made a connection with in a traditional manufacturing meaning.
So I think you know a little bit about what we do at BlueForge, and so we of course are very interested in supporting the Navy and particularly the submarine industrial base. How does what you're doing, or does what you're doing, potentially support the Navy and shipbuilding?
Perfect. So it's kind of two ends of the spectrum. Most people think you need to print the final part, and we have demonstrated the ability to actually print tooling, if it was for casting, if it was for forging, or if it was for fiberglass components, right? So traditional composite manufacturing. And we've been able to demonstrate the ability to use high temperature autoclave suitable materials like Ultem, Peaks, PEX, and print them near net shape, already maybe 90 to 95% of the final shape of a composite tool, and then have the ability to do final facing of that tool so you can actually use it in a relative time period, right? Right now, a big area for those guys is time and energy to be able to produce new prototypes or new final parts. So tooling was big for these for our applications in the naval shipyards and also within the naval warfare centers. Prototypes and large scale up parts have been a big emphasis for these guys to be able to demonstrate something in a quicker time period. So that's been able to mock-ups or actual trying to print structures that would either replicate or potentially be the final components of what you would see on a unmanned vehicle or even final mock-up for an actual component in a submarine.
For your high temperature layup toolings that you're printing, how does it compare with traditional tooling in terms of both time and cost?
Well, we can tell you on the time essence of things, we're printing tooling less than a day, right? So the tools that you're able to produce, as long as you can design them well, they're suitable for the technology, they're printing in less than a day. And then with what we're doing is really much kind of lights out technology. Set that printer up, walk away, come back within 8 to 10 hours, and your tool's completed. You do have to have the secondary operations, right? You have to be able to put this on a mill or a router, mill down to get your final surfaces, potentially even coat these parts. So we're talking in less than a 1 or 2 week period, when right now tooling could be upwards of 12 months. So we're able to drastically make a difference when it comes to the timing. And cost, somewhat subjective. The plastic is going to be cheaper than the metal, but people are always going to say that maybe metal is going to last longer than plastic. That's a no-brainer. So you do have to kind of weigh out those options of what that, kind of price point matters most when it comes to making something out of metal, making something out of plastic, when it's timeline and price cognizant, right?
Okay. And certainly when we're talking about shipbuilding, most of what we're interested in is metal.
Right.
And so you are making tooling for casting. Can you talk a little bit about that?
Yes, that is the low-hanging fruit, right? So when you think about traditional sand casting, and you think about having to make the tooling for a cope and drag of just floor sand molding, it's the perfect print, right? It has natural draft. There's no overhangs. There's nothing that's going to be too critical. They even think about support material or anything like that. What they care about is it's a reliable material that's price cognizant. Print your tools in your cope and drag fashion like you would if you're making it the old-fashioned way, and then machine that down to its final surfaces. And we've been able to demonstrate that the time to produce a cope and drag hard tool pattern is much faster than the traditional way. And we're also talking about one of the oldest technologies, or the oldest manufacturing processes in the world, next to forging, right? And so we're running out of people that know how to build patterns nowadays, right? They're, the pattern maker is traditional journeyman, right? Just like a tool and die maker. And we don't have the young group, a generation coming in to learn how to scope out and map out the new patterns. So getting into this Industry 4.0 and the new digital era, we need to have technologies that are suitable to be able to produce these parts.
So what's next? What's new? I've seen your latest printer. It's a Goliath.
Yep.
Where are you headed?
We're going bigger.
Okay.
We're also venturing into new materials. So we were recently awarded a congressional project with American Makes and through AFRL to develop a hybrid technology, large-scale system that does both thermoplastics and thermosets. So thermosets are new. People are very interested to see what you can do with them. So with the thermoset, this is more of like epoxies, polyurethanes, silicones. These are materials that once they mix, they're not coming back apart. So the big difference obviously is, thermoplastics have those ability to be melted down over and over and over again. A thermoset is really a one and done kind of deal, right? We're mixing a part A and a part B to give you your final output. However, what we're able to see with thermosets is we can see higher temperatures. We can see lower CTE, or coefficient of thermal expansion, what people care about when it comes to tooling. And we're also able to see better isotropy. So big problem in additive right now is that majority of the technologies is a laminate. It's a 2D printing layer upon layer. 3D printing is really kind of weird concept. And so you do have anisotropic properties in between those layers. With thermosets, you have the ability to actually cross-link, have a more of a chemical reaction to get better resistance in the Z-axis. So thermosets is a new endeavor for us, and we're really excited.
Well, that's exciting. Thank you so much for taking the time to talk to me today. I continue to love hearing about what you're doing and look forward to seeing what's next.
Thank you.
Thank you, Zach.